give me great pleasure to introduce our final speaker. I'm only doing that joke now.
I can't wait this.
So this is Sasha from OneSpin Solutions.
Thank you. Okay, so today I will try to answer your questions from today. So how OneSpin can solve the problem of matrix. And I will just give you a few words on the company first. So we are basically a spin-off of even Siemens, and then we became Infineon, and then from that we became from another spin-off, which is OneSpin. So 25 years of real experience. So already at that time when the team was at Siemens, we started developing the tool itself. So basically what was first developed were the checkers of the tool. Of course, they've been developed further, but that's the first thing that came. So based in Germany, we have a new investor, so dramatic growth and investments. And we came up with quite some product lines recently, so in order to improve our time to market and quality you can get. Okay, some of those words are also here, so I will just highlight the 3 bullets. So really high value and usability. So 25 years, so really a pioneer and leading technology, and our real focus is basically the user. And last but not least, from the company perspective, this is basically the product lines we have. One product line is here and above. So we have a design verification solution with 3 levels and a bunch of push buttons, which are really push buttons which generate the property for you. And all the way down we have a solution for equivalence checking. And where we see ourselves the most is the FPGA, and new thing is RTL to RTL, and sorry, and sequential checker we have. That's really the sequential checker we can run on any of these. Okay, now the real focus on the slides we have here. So I will first tell a few words on why the metric is so important. Then after that I will try to explain the controllability and observability of the RTL and the properties you have, and what is the practical coverage, and how then to combine those two. And just in 2 slides we'll give you an example how is that implemented and how it looks like. Okay, we asked ourselves why. Well, no matter if you do simulation or formal verification, so whether you have some bus functional models or on the side of input side some constraints, you have, of course, in a sense of your checkers, you have simulation checkers, or in formal world your assertions or properties. The verification process cycle is about planning, doing, checking, and acting actually. So first you develop your verification plan, then you create your test benches or properties, and then you verify them, and then you ask yourself, are you done? Of course. And do you still make any progress? So even if you write maybe some extra properties, it can be that you are still stepping where you are. And then if your checker saying that you're not done, then the idea is to adopt the planning before getting to tape out or just going to tape out. And for that, this progress metric is the key component which you run. So someone asked during this presentation, you can run it anytime. Okay, that was a live question actually, yes. So the good thing is that you can run it as soon as you write your first assertion. what it covers, right? So any time of the verification process, you can just use it and run it. Okay, for the standard assertion-based verification, first problem is the progress. So answering how many assertions to write, where to put them, and to follow the progress of the design that is verified. And then at the end of the day, what is the quality? So do we satisfy certain quality of our criteria? Another problem or issue is the integration with the simulation. So can we really integrate our formal result, for example, with the simulation result? So for that reason, that is really a weak integration at the moment, and you usually need to have some additional effort. And due to that, formal tools are used as a point tool or for a purpose of finding only the corner cases. And that's one of the main reasons almost for the low acceptance of the formal assertion-based verification. And then we really need a practical way to resolve this issue. Okay, so if we look at the taxonomy of the progress matrix, we can have one way, general way, which is bug rate or the density of our assertion set. Or what I will focus today is the coverage matrix, which can be structural functional. Thanks to Tim, I will not have to be bothered with the functional matrix, so you heard a few words about gap-free verification. So if you really want to prove 100% of functional verification of your design, your IP, you can go for gap-free analysis, which really guides you how to verify the functionality of your design and when you're done. But today, the rest of the slides will be really focusing on answering the question, have we written enough tests, and all other questions we've heard today. So focus will be code coverage, mainly line statement or blocks. Okay, okay, I have this too. Yeah, so this slide will mainly focus on controllability and observability, so the input side and the output side. So for the coverage matrix, how much did we verify and when we are done? Then, from the stimuli perspective of view, do we have enough text vectors or informal world constraints? So do they do what they should? And on the other side, on our checkers or assertions, how good they are. And for the control or simulation coverage, we really focus on the stimuli. So that's what we observe. And then to judge the quality of the checkers, we do an observation coverage. So we really look at the checkers we developed. And we, for that, use exposes unverified UV parts. Okay, so two main questions are, have we been there and have we done that? So been there means, are we able to control a certain line? And that refers to the controllability. So can we get to the line done output gets 1? So can we reach that? And then we also follow the mutation. So how do we verify that? The idea is to mutate certain line and then to find among your checkers which fails. And then if there are any, that means that you have observed that line. But we will also see that in the example. So what is the whole idea? With the controllability, we measure the quality of our stimuli, and in the case of observability, the quality of our checkers we developed. Okay, so if we go to the formal world, a little bit more about the control coverage. So in formal, your formal engine will take care of generation of your stimuli. So you will have an exhaustive set of stimuli, and then you can ask yourself, why do we need controllability? Well, in many cases, or almost every time, you need to develop some constraint to basically exclude the illegal behavior. So maybe you cannot have two signals being set at the same time, and for that purpose, you just write a constraint. I mean, in a case of even of a FIFO. So being full and empty, that's illegal, right? And for that purposes, we need to observe our constraints, basically, and the code itself. What that means is that from the control perspective, we have lines which are controllable or uncontrollable, or that we still do not know what do they do, or can we get there, but most likely the tool didn't finish yet. And for the controllable part, can we reach that line or not? Or if the line is not controllable, so if it's uncontrollable, we can have some dead code or redundant code, so the tool will tell you even the line is dead or redundant. Or worst scenario is that basically you will have a line which is constrained out. So the developed constraint set really excludes that part from the verification, basically. You can never get there with your assertion set. And that's basically the whole story about the controllability. Similar thing is with the observation coverage. I mean, a bit difficult to explain, but from the verification perspective, we need to answer the question, does the design satisfy our specification? And for the observation, what causes the design to satisfy given specification? So this line is something I will really not read, because I read it 5 times and then I understood it really in my head. So that's basically about the common approach. So observation coverage literally looks into the quality of the checkers you've been developed. So how good they are, and for that purposes, if you are still running, most likely you will have some parts which are unknown, then parts which are observable, and of course parts which are not observable, and that mainly relates, why they are not observable mainly relates to the controllability part, because you cannot observe something if you have constrained it out, of course. And then this tool basically squares tells us, okay, with our assertion set, we observe certain line or statement or not. So what is the idea and the practical usage? So we also, as I said, use the mutation. So the mutation can be like this, so like replacing A equals B with A equals to 1, but it can be that that leads to the vacuous holding assertion, which is of course not good. And I mean, it can require a lot of modifications which can increase your runtime. In our solution, which is mainly called Quantify, so our metric-driven solution tries to replace our example, which is A gets the value of B, with A gets value of some signal, some value. And then when you mutate it, you can definitely have cannot have some vacuities. And the good things are that you can trigger multiple locations and have faster results. Okay, a typical example, or let's say one example, can be this. So we have 5 locations and only one in the design. So this is basically the boundary. In the design, we have 5 locations and one assertion which states that if our index is 1, the value of z will get, in next call cycle, we get the value of A. And obviously, we will only cover the green or our coverage point L2. How do we do that? So how to achieve? So we first split into a module and the assertion set, and then we ask ourselves which assignment in the design are observed. And for that purpose, the answer is simple. So if the assertion fails after the mutation, we know that we've been there and that we did something. So we modify each location and we get something like this. So we get for the reset statement some input, and then for M2, M3, M4, and M5. So we generate this 5, and then we run the assertion on them, and the assertion fails, which is in our case good. We will say that we have observed that piece of code. Okay, the results. So we have a nice table. If we have observed something, that definitely means that the line is covered, because the control coverage is following the same thing. So if a location is observed, that actually means that automatically it has to be controllable. Because if we can get there with our assertion, definitely we can trigger that location. And then a lot of different things, but I will go, or combinations, but I will go all the way to the end. So if we cannot control a line, so it's redundant, dead, constrained, we definitely cannot observe it either, because there is no way to get there anyway. Okay, so this slide mainly gives a comparison and how to basically merge those two. Okay, so we also support interfacing with the UCIS, so Mental Graphic UCDB. Well, it only supports control coverage, of course. So what is the idea? So first you need to use user-defined structures to store the results we got from one spin, and then you use those results to enhance standard UCIS coverage. Okay, so these are basically the results you can get. So after merging from to Quantify and merging Quantify to UCIS. I mean, this is indeed very useful, and that's something you asked for actually. So, and one final comment would be that really direct support for observation coverage is desirable by the UCIS. Okay, and this is the result after running the Quantify. So the output basically after running it is the HTML, and you can of course see that in your browser, and with the green you will highlight lines that have been verified. Then you have some verification holes. So basically you don't have an assertion which covers this piece of code, and also you have a constraint which doesn't allow your verification or assertion set to even get there in any way. So you just know that that's constrained out, or that in this example that there is a part of the code which is dead. What is nice, you can really see the percentages. So good for you, good for your management. So how you stand basically. So you see that we have covered 35% and still have some constrained things and stuff. most likely we cannot get rid of this dead because it's a default case statement, of course. I mean, you can take it off, but no needed. The point is that you understand what is the problem. Okay, and then some examples that one of our colleagues ran in the tool. So let's look at, I don't know, this FSM of DDR2 read. So you have 800 line of code and 6 assertions and 93 locations. So it managed to finish in less than 2 minutes. However, this huge design was running for 7 days and didn't finish. I mean, we had to interrupt it after on 80% of the completion. So even if you interrupt it at the stage you interrupted it, you will get some results. So the tool will give you the results of, okay, this part is verified and the other things. So 20% was unknown, basically. You got the result of unknown. Okay, the summary itself. So we agree that this coverage is very important part of the verification. Still, I would say that, again, this is not doing any functional verification of your design. So you cannot prove anything on the functionality by running the Quantify MDV. I mean, the sweet spots are you can combine observation and control coverage at the same time. You can also combine it with the simulation you did. It really doesn't matter the way of or the language and the style you're using, either for the design or the verification. Also, you've seen on the previous slide, you can really run it on some big industrial design. So good is for finding coverage closures, ways, and of course for your management to see, and of course you as an engineer where you stand. Okay, that will be basically it from my side. If you have any questions.
Any questions?
It's more from the other side. There was not talk in the presentation, the gap-free verification.
Okay.
They were saying that is more for the functional.
Yeah.
So I think could we say that if we have the gap-free verification completed, then the Quantify MDV is 100%. So it's like it's covering the coverage, you know, that this is something state.
Well, depends, but I would rather say you should use Quantify as an intermediate step to see how you stand, and then if you have 100% of functional coverage, do you even need Quantify at the end of the day?
It's a question. It's not automatically 100%.
Yeah. Exactly.
Okay.
Thank you.
Any more questions? Thanks.
So if you've got a line that's not been covered, that's not been observed, I guess, and you want to sign it off, presumably there's a mechanism for doing that. And can you, on later revisions of the RTL, is there a way to link that sign off across later revisions of the RTL, so you don't, every time you rerun it, you don't have to keep signing off the same thing over and over again?
Well, if you change anything, unfortunately you need to rerun it. I mean, if you change the RTL, for sure, you need to rerun your tests and everything. But it is also possible, for example, if you change any property, you don't have to prove it. So if I answered your question, if I understood it correctly, maybe I didn't.
Well, so is there a way of signing off a?
Well, it's your decision.
So let's say there's some redundant code, that you want to leave in, so you know that that's not going to be detected. Is there a way of saying that's redundant. I know about that. I don't need to look at
Yeah,
it.
yeah. I mean, you will find that this table, basically, and you are aware of that, and you are fine with that.
Yeah, but the next time you run it, is it marked as a green or is it marked as a red?
No, it's always redundant.
Okay.
It should not be marked that way because that is that, and you cannot cover it actually. So if the line is redundant, then you cannot cover it at all. Yeah.
Yeah. Is there some way to mark it in the RTL that I don't care about this, don't show it to me ever again?
Yes, there is a way. There is an option, command option, to skip that.
Okay. Right, I know we're nearly done. We are going to invite our
Okay, thank you.
PJ vendors back. Oh, sorry, thank you. Thank you very much to Sasha.